So, have you ever stopped to wonder why some countries consume just massive, mind-boggling amounts of energy, while others barely even make a dent in the global grid? Well, in this explainer, we are setting out to solve that exact global energy puzzle. We're going to decode the true determinants of energy usage, break down the actual numbers, and really look at the underlying forces to discover what exactly makes those power meters spin so fast around the world.
Let's start right here with the million-dollar question. What actually drives a nation's energy use? Now, if you had to guess right this second, your first instinct is probably the most obvious one. You're likely thinking about population size, right? And hey, it makes total sense. More people naturally means more cars on the road, more houses to heat, more infrastructure, and obviously more power demand. But is it really that simple? Well, actually, let's let the data answer that for us.
Okay, let's dive into this. When we look at the data for energy supply per capita, meaning per person, some pretty striking disparities emerge right away. At the very top, you've got places like Iceland, Canada, and the US literally burning through enormous amounts of energy per person. But then you scan all the way down to the bottom of the list, and you see countries like India and Indonesia using just a tiny fraction of that. I mean, we are talking about an absolute order of magnitude difference between the top and the bottom.
To really put that population theory to the test, let's just compare the United States and China. According to the data, these two nations were essentially tied in their total energy consumption. But here is the real kicker. China has more than 4 times the population of the US. 4 times! That pretty much completely shatters the whole more people automatically equals more energy myth. Because of that massive population gap, China's per capita energy use is actually less than a quarter of America's.
To put that US per capita energy use into perspective, just look at this quote. The energy use amounts to the equivalent of 100 100-watt light bulbs burning continuously for every single person. Imagine that. 100 light bulbs on all day, every day, just for you. That is a staggering amount of power flowing every single second. It's almost twice the usage you'd see in Germany or the UK, and it's 4 times the world average of 1.82 tons of oil equivalent, which, by the way, is simply a standard baseline experts use so they can compare massive blocks of energy. So, clearly, population cannot be the dominant factor here.
So, if it isn't just sheer numbers of people driving the meter up, what is it? Well, the true heavyweight driver turns out to be gross domestic product, or GDP. Yep, it's the economy. The most important factor in a country's total energy usage is its economic activity. It's the total sum value of all the goods and services that a country's residents are producing in any given year. Basically, wealth generation equals energy consumption.
Now, what's really interesting about this slide is how we measure that relationship. We use this absolutely crucial concept called energy intensity. And this is simply the ratio of energy consumption to a country's GDP. You can kind of think of it as a measure of a nation's mechanical and economic efficiency. It tells us exactly how much energy a country requires to generate a specific dollar value of goods or services. And when you group these energy intensity levels by country, an amazing pattern emerges from the data. Almost all of these countries fall within 50% of the world average. They're basically clustered together. This relative constancy is the absolute proof that GDP is indeed the dominant factor determining a nation's energy needs. In fact, industrialized societies generally need about 8 megajoules of energy to pump out just $1 worth of goods or services. But here's the thing. Energy intensity isn't just some static, unchanging number. There's actually a fascinating life cycle to it. The energy to GDP ratio typically spikes really sharply when a country first starts to industrialize. They're building things, pouring concrete, laying roads. It takes a ton of power. But then, as their infrastructure gets more substantial and much more efficient, that ratio actually drops. Look at the historical proof for a second. The US ratio dropped by a factor of 4 over the last century, and China is following that exact same playbook, with its intensity falling 19% between just 2005 and 2010 as they modernize their manufacturing.
Let's move to and see how this builds into a cohesive framework. We've uncovered 3 vital steps to our puzzle today. Step 1 is population. Step 2 is the GDP per population, which basically measures the affluence or wealth of those people. And finally, step 3 is energy per GDP, which is that energy intensity factor we were just talking about.
So the crucial point is how these 3 elements lock together perfectly. Look at this master equation. Total energy usage equals population multiplied by GDP per population multiplied by energy per GDP. If you remember your middle school math, the populations cancel out, the GDPs cancel out, and you are left with just energy.
It's a brilliantly simple mathematical truth derived from incredibly complex global systems, showing us exactly how these determinants combine to dictate global usage.
Looking ahead, the data projects that global energy usage is just going to keep increasing in the coming decades, growing at a rate of roughly 1.2 to 1.5%, specifically because of rapid economic growth in developing countries. And yes, gradually increasing efficiency will absolutely help temper this rise. But I want to leave you with this provocative thought. As our global economy relentlessly expands, will those efficiency improvements actually happen fast enough to balance the scales of our global energy puzzle? It's a massive question, and frankly, it's one that's going to define our future. Thanks for exploring the data with me in this explainer today.